continuing what I had in my first video, the second section of this paper, they define the electric and magnetic fields, and they get some modified Maxwell equations, which are these. So they get these modified Maxwell's equations, and using these with a specified Lagrange density, they come up with some boundary conditions. And the physical meaning behind why they're doing all of this in the second section is just to introduce the mathematical model that defines the amount of radiation that the bubble gives off. After this section, what the model has yet to account for is that the fact that the bubble emits radiation. As the bubble emits radiation, it also loses its size. So we have the bubble and it emits radiation. As it continues to emit radiation, it starts to lose its size. But also, as it gets smaller, the amount of radiation that it's emitting intensifies. So the rate at which it loses its radiation is increasing. In fact, it's increasing exponentially. So in this section, they adjust their model to account for the dissipating gas bubble, which is what would actually happen. So they make their model grow exponentially. So looking at a graph of radiation versus time, it would just grow exponentially. So as time goes on and the radius gets smaller, it emits more radiation, more light. But there's one major problem. Eventually, the bubble stops emitting radiation so rapidly, it just gets small enough that it doesn't continually emit radiation at such a high rate. So after it gets to a certain point, at a certain time, then the radiation starts to just gradually decrease. And this is a part that they hadn't accounted for in their model. So in the conclusion of their paper, they acknowledge that the radiation being given off by the bubble might not be in fact due to vacuum radiation, which is what they assumed it was in this model. But what they suggest is creating the radiation is with this boundary of the bubble expanding and contracting, and that being coupled with the electric field and the magnetic field at the boundary. They say that in of itself is what creates the light being emitted by the bubble. From there, they say to improve the results of their model, they need to add a mechanism that accounts for this section here, this slowly dissipation that stops the exponential growth. And they also need to quantize, they could quantize the electromagnetic field for the dissipating bubble model. So basically just being able to make it so that the electromagnetic field is able to be measured. So even though this article does not say for sure that vacuum radiation is the cause of sonoluminescence, if it is found in the future that vacuum radiation is in fact what causes it, physicists can use this paper as kind of a head start for modeling it.